Hi there, it's Jason Gorman here with the second in our video series on test-driven development in C#. If you haven't seen the first video, there's a link in the description below, and I highly recommend that you watch that video first before watching this one. Now, if you did watch the first video, you may recall that we looked at the 3 steps of the test-driven development cycle. We start by writing a failing test, and that acts as a specification describing something that we want the software to do that it currently doesn't. Then we write the simplest code we can think of to get the test passing, get it passing quickly. And then, if necessary, we refactor the code to make sure that it's going to be easy to change going forward. So make sure that it's easy to understand, make sure that it's as simple as you can make it, and other things that we will look at in later videos. So, write a failing test, then write the simplest code to pass that test, and then, if necessary, refactor the code to make it easy to change going forward. And we repeat that cycle over and over again, fleshing out and generalizing our solution design with each new test case until we have a complete design that is the simplest thing that will pass all of our tests. And that, in essence, is test-driven development. If you're doing those 3 steps over and over again, then you're doing TDD. But there is more to TDD than that. You can do it well, you can do it badly. And what we're going to be looking at in this second video is 3 good habits to try and get into when you do TDD that will make it easier, more effective, and more sustainable. The first habit we're going to be looking at is writing the test assertion first and then working backwards to the setup. So assert first. And then we're also going to be looking at why it's a good idea to run your test and see that it does fail before you make it pass. And then finally, we're going to be talking about how many questions we should ask in each test. How many reasons should each test have to fail? And we tend to find that it works best when our unit tests only have one reason to fail. And we'll talk about that last. So I'm going to be using a very simple example of a community DVD library where people can donate DVDs to the library so that other people in the community can watch them. And donating a DVD is a very simple process that has 2 outcomes. First of all, that DVD, that movie, is added to the catalogue in our library. And secondly, we register 1 rental copy with that donated movie so that people can borrow it. So we're going to be writing unit tests using NUnit 3, and we're going to start by writing a unit test for donating our DVD. There we go, using the test attribute. If you're not familiar with NUnit, then I'll post a link to the NUnit documentation in the description below. But all we need to do to say that a method is a test method, that is, it's a test that can be executed by the NUnit test runner, is you describe it using the test attribute, and then your method is a public void method with a name usually that describes what the test is. So donate DVD, and we'll talk in a little while about why that's not such a great name. Donate DVD, like so. So that's our test method. That's what the NUnit runner will recognize as a test and be able to execute. Let's fill in our references there to the NUnit framework. You'll see in my file above there. So we're using the NUnit framework, which is where the test attribute comes from. Okay, now in the first video, you will notice that when I wrote my test, I sort of started at the beginning by setting up the objects and the data that I needed for my tests. And this is how a lot of people do it. So they would say, well, we need a movie to donate. So let's do that. And then so on and so forth. So they declare the objects they're going to use in the test. And then they write the code that calls the method they want to test. And then at the end, they write assertions about what should be true if that method has worked correctly. But we have found over the years that actually TDD works better as a design process if you start by asking the question you want to ask. So we're actually going to start by writing an assertion. Let's make this assert true. So we're going to start by writing the assertion first. So imagine we have a library, and let's imagine our library has a catalog. And we're saying this catalog contains a movie. So we've referenced a bunch of stuff that doesn't exist, and we're going to work backwards. Let's create that local variable for library. Working backwards from there. So now we're saying, okay, we need a library class. Oops, that's not what I meant to do. We need a library class, so let's create that. Okay, and it needs a catalog property. So let's create that. And we can probably do it as a get only, I would think. Yep, that'll do. And that's going to be a list of movies. So let's import this for a start. Okay. Again, we've got to create a class. So the test is telling us what we need to have here in order for this code to run. And let's create our movie local variable here. So I'm working backwards from the assertion. Okay, I can probably doesn't really matter, but we'll create the movie first, then the library, and then we perform the action we actually want to test, which is donating the movie to the library. You can create that method. See how the tool is helping me here. Just a short note, by the way, if you're working in Rider or you're working in Visual Studio, the way that these IDEs are set up by default is that they will try to autocomplete. So if you're typing code that references things that don't exist yet, the IDE will look for something that matches that name and try to fill it in automatically, and that will get very annoying. It'll feel like you're kind of wrestling with the tool because you're trying to reference things that don't exist yet if you're working backwards. So what I do, let's see if I can find the setting for you. Take a look in our settings. So under editor, under general settings, you'll find settings for code completion. And what I've done is that option there, insert selected suggestion by pressing enter dot parenthesis or whatever. That suggestion there for auto completion, I switch off so that it doesn't do that for me, which makes life a little harder in some respects. But it means that it's not always trying to autofill, always trying to autocomplete. Now, donate, let's make that null. And there's our catalog. Okay, for now, let's just make sure that it's not null. You'll see why in a minute. So let's just return an empty list. Now that I've done that, working backwards from my test assertion, I'm going to, before I write the very simple code to pass this test, I'm actually going to run this and make sure that it fails. And I'm going to make sure that it fails because the assertion is failing. So we should get a failing test because our catalog is currently empty. In other words, it doesn't contain our movie. Now, why have I done that? Why is it important to see that the test assertion fails? Well, going forward, one of the nice side effects, one of the spin-off benefits of using tests to specify our code is that we end up with not just code that hopefully does what the tests require and nothing else, but also a suite of regression tests that, if they're well written, will run fast. And they will, going forward, as we evolve and change our code, they will protect us when we break the code. They will alert us straight away, but only if they're good tests. In other words, only if this test will fail if that assertion is not true. In other words, if for any reason we break this code and our movie is not added to the library, then this test will catch that. So test your tests by running them to make sure that the test assertions fail when the result is wrong before we write the code to pass the test. So now let's do the simplest thing that we can think of to pass this test. The movie's got to be in the collection. So let me just get rid of that. Let's imagine we have a private field here and create that. Okay. That ought to be working. What's it complaining about? Cannot resolve this. Ah, yeah, we need to give it a type, don't we? I keep forgetting that I'm not in JavaScript now. Okay, so it's a list of movie. There we go. And all we have to do is add our movie to that list. And that should, with any luck, work. Lovely. Okay, so far so good. We're at a passing test now, and when our tests are passing, it's time to think about whether we need to refactor, and the answer is yes, I think we do. I don't think these solution classes belong in the test fixture because that's just going to get very confusing. But to make it easier to understand, let's move these to their own files. And you'll notice as soon as I do that, I rerun my tests. So the tests are protecting us, which is why it's important that they are good tests. So make sure that you're confident that if you were to break that bit of the code, your test would fail. So see the test fail first, okay? And I think we should move library to its own file. Okay. Okay, now the convention in the .NET world with unit tests is that they're not part of the same project. So what I'm going to do here is I'm going to add a class library project, which is going to put our core logic in, our library and our movie. Let's call it TDD library. And let's spell it correctly, Jason. There we go. And okay, so far so good. And what we're going to do in our DVD library, let's clean that up a bit. Let's get rid of the auto-generated class. And what I'm going to do is I'm going to move library into what do we want to do? Hopefully it will fix the okay. It's going to fix that for me, so it's going to add references to our. Hopefully it will figure that out in a minute. That's interesting. Interesting that it hasn't fixed that. I guess we need to move movie across as well. And hopefully it will fix the references. Okay. And that means it doesn't appear to have done that. Let's add a dependency, let's add a reference to this project, and that should fix it. Okay, that took a little longer than planned, but now we should be able to run our tests again. So our core logic is now in its own separate project as per the convention for .NET. Our test is passing, And we've got one more thing we need to add here. As well as adding the movie to the library, we also need to think about number of rental copies. So the movie should have exactly one copy. And again, working backwards from there, let's create that property copies. So far, so good. And back to our test. So at the moment when we run this, we're probably going to get an error. Let's see that fail. Okay, yep, expected 1 but was 0. That's exactly what we would expect to happen. Okay, now, in order for this to work, we could have library set the copies on the movie. For example, like that. And hopefully that will work. Okay, so that's working. Time to think about refactoring again. I'm not entirely happy about the way that copies is unencapsulated there. Maybe library shouldn't know how we're storing the number of copies. So we might decide to create a method specifically. Let's call it add copy, for example. Create a method for doing that. And I actually don't want that to be static. Didn't notice that. Okay, so let's look for a make method non-static. Thank you. Look at that. Done it automatically. So it figured out this should be an instance method of movie. Hopefully our tests are passing. And now when we took a look inside movie, we can actually make this private and it should still work. So the only class that can change the number of copies is movie. Okay. And there's one other bit of encapsulation here that we probably need to add. Maybe we shouldn't be exposing this internal catalog. So let's extract a method for that. And let's call that contains movie. Okay. Again, let's rerun our tests. And now we're going to make this non-static. I can never remember what the shortcut is. I don't think there is a shortcut for this one. Okay. And we're going to move it as make it an instance method of library. Okay. So we're hiding some internal details here. So we don't really need this catalog getter anymore. We can make that private. So again, we're hiding some of the implementation here. We're encapsulating that. Okay, that's almost all the refactoring that I would need to do. There's just one more thing that's bugging me here. Now, this test asks two different questions. It asks whether the library is, whether the movie's been added to the library, and it also asks whether the movie has been given a rental copy. So this test has two reasons that it could fail. It could fail because something's gone wrong with adding the movie to the catalog, or it could fail because something's gone wrong with updating the number of copies. And that means when this test fails, it's less clear what the problem is. Ideally, what you want is tests that when they fail, they pinpoint exactly specifically what's gone wrong, exactly what has gone wrong here. And that's why we tend to find that it's good practice to have tests that only have one reason to fail. And one way to do that, if we were to refactor this, might be, let's just let's start by actually making movie and library fields. Okay, you'll see why I'm doing this in a minute. So these are both fields now. And then I'm going to extract the setup into its the first part of this into its own method. So we're going to make that so let's call that setup, and we're going to make it public. You'll see why in a minute. Let's just run that. And now what we're going to do with our setup method is we're going to turn it into an NUnit setup method, one that's tagged as should be run before we run each test. So when we do that, the NUnit test runner will know that it needs to run that setup before running each test method. So it should still all work just fine. I'm going to move this above here because it really needs to come before the test. Notice how often I'm running my tests after each change. That's very much the art of refactoring. And now what we can do is we can extract a second test method. Let's call it copy added to movie. Okay, just going to run that. Let's just make that public. And I'm going to say this is actually another test method. So the NUnit test runner will run the setup before each of these tests now. Okay, we need to run them all. Lovely. And we can rename this test so to say what it's actually about. Movie added to library. So when our tests only ask one question, that not only makes it easier to pinpoint when a test fails exactly what's gone wrong, because our tests are very specific, but it also helps us to name our tests so that they're much more descriptive about what is this test about. Well, the first test is about adding the movie to the library. The second test is about adding a rental copy to the movie. So tests that act as specifications should read like specifications. So when we're reading our test fixture now, we look at the name of the test there. Donate DVD test is the name of the fixture. And then we've got a list of things that should happen. We can just read the names of the test methods if we like that describe what should happen when we donate a movie to the library. So there's 3 habits that are worth getting into when you're doing your TDD cycles. Number 1, write the assertion first and work backwards to the setup. So you end up with exactly the setup you need to ask that question. Takes a bit of getting used to, and if you're working in Rider or if you're working in Visual Studio, you might have to configure your tools to make that possible, make that easier, because autocomplete in particular will fight you all the way. And on top of that, make sure that you're running your tests to see that they really do fail when the result is wrong. Not fail because of an unhandled exception or a not implemented exception or one of those things, but it fails because the answer is wrong. So we can have confidence in that test going forward that if we or someone else were to break this code, that test would catch it. And finally, we find it is a good idea if tests only have one reason to fail. So when they do fail, it's pretty obvious what's gone wrong, but also the names of the tests can then more easily communicate what that test is about. So tests read more like a specification. Okay, so there's 3 good habits for test-driven development, and I will see you in the 3rd video.